what we discussed in our activity was that a right triangle is a triangle with one right angle. Besides having a right triangle, a right angle, a right triangle also, there are specific relationships between the legs. The legs of a triangle are basically what they call the sides. And the legs themselves, they assign different letters to it for variables, like when you don't know them, where the longest leg is what we call the hypotenuse, which is the one that's opposite of the 90-degree angle. And if you think about it rationally, the reason that the side that's opposite of the 90-degree angle is the longest is because the 90-degree angle within that triangle is the biggest angle. Why would you say, or can you tell me why the 90-degree angle is bigger than any of these two by themselves? Because of the fact that the hypotenuse is opposite of the 90-degree angle, it is the longest leg because the other two angles, the legs that are across from them, have to be less than 90 each, which means that the smaller the angle, the smaller the leg it creates. Now with that, the Pythagorean Theorem was when, back in ancient Greek times, a guy by the name of Pythagoras actually had all sorts of different meetings with other philosophers that were interested in finding patterns in the world, mathematical patterns, and they discovered that there was a direct relationship between the legs of a triangle and the hypotenuse of that right triangle. And that relationship is what they call a squared plus b squared equals c squared. So, you can use that rule, that formula, to find the missing side of a triangle. If, for example, you're asked to find the missing side, you can either be asked to find the hypotenuse length or one of the legs. So if they give you two legs and you have to find the third leg, you use the Pythagorean Theorem. If they give you two legs and they ask you to find the hypotenuse, that's one scenario. The other scenario is if they give you the hypotenuse and one of the legs and they ask you to find the third leg. So if I looked at this formula, this is where I would look at my triangle first. What is given to me? I am given the legs of the triangle. What are they asking for? The hypotenuse, correct? So if I was to assign letters to 4 and 6, I could say that 4 is A and 6 is B. Yes, exactly. Or you could interchange the two. You don't have to always assign A to the smallest and B to the second smallest. I would always do that at first just because that would make it so that it would prevent me from making errors. So if I know that A squared, so here's my A, let's say I call this A squared. A squared plus B squared equals C squared. Then A is 4, so I would say 4 squared plus B squared, B is 6, 6 squared equals C squared. And again, you could interchange the A and B. You could say A is 6 and B is 4. After I do this, I would realize that 4 squared is 16, 6 squared is 36, and remember I do order of operations. You do exponents before you add. And that's equal to C squared. And then I do 36 plus 16. 6 plus 6 is 12, carry the 1. 1 plus 3 is 4 plus 1 is 5. 52. So I get that C squared is equal to 52. Now for this specific question, it's going to be a little bit weird because you're going to get what we call an irrational number. 52 is not a perfect square. What's a perfect square? So I know that a perfect square, when I look at the shape, has 90-degree angles and all 4 sides are equal. But what I'm referring to when I say a perfect square is a number. Can you give me a numeral that is a perfect square? 36 is a perfect square. Bennett, how do you know 36 is a perfect square?
I just guessed.
Can you think of a number that squares to give you 36?
Oh, 6.
6. So a perfect square is a number that can be created through multiplying something by itself. There is nothing that is a perfect square. 52 is not a perfect square. Nothing times itself gives you 52. The closest thing is like 7, because 7 squared is 49, and then 8 squared is 64. So it's somewhere between 7 and 8. So this is where we lead into the idea of, how do I solve a square? If you're told that something squared is equal to, for this instance, 52, to unsquare it, you take what we call the square root. In this example, you would say c equals the square root of 52. And for the sake of this example, because of the fact that we don't know the exact square root of 52 off the top of our head, you would just leave it as the square root of 52 because you can't take it. Or if you push it on your calculator, what you would do is you would put 52 and then the square root symbol. And it would give you 7 point something, rounded to about 7.2. For the sake of your practices in this class, you are going to be given perfect squares. Let's look at an example. Here, what is the missing length? The A, the B, or the C? Yeah, it's X, but it's the C, right? How do I know it's the C? How do you know this is A and B? Because, correct, these are the two legs. There's my 90-degree angle. This leg is opposite of the 90, which means it's the hypotenuse. So as you guys said, that would be what we call the C. So 8 and 15 are the A and the B. Whenever you're given a right triangle, if you're asked to find the length of the leg, you use the Pythagorean Theorem, which is a squared plus b squared is equal to c squared. You already said to me that A was 8 and B was 15. C is my unknown, okay? C, not c squared, C. They want to know what is C equal to. So then I follow the steps like I know. Order of operations, 8 squared is 64. 15 squared is 225. That's what C squared is. Together that adds up to, okay, so 225 plus 64 is 289. And if I know that C squared is 289, then they're asking me, well, what is C? Like, what times itself gave you 289? Well, you could either memorize your square roots, or you could actually go, oh, I got to take the square root of that, which is 17.
How do you know? Can we use a calculator?
So on a calculator, what you would do is you would so you would take 289, and then you would press the square root symbol, and it would immediately give you 17. So if I was to give you guys this example here, in this case, I know that they're asking me for A, B, or C. So I know that X is the C. So I look at it and I go, oh, I look at that. It's a right triangle. Oh, yeah, right triangles use the Pythagorean Theorem. And the Pythagorean Theorem is A squared plus B squared equals C squared. A is 5, B is 12. So 5 squared plus 12 squared equals X squared. 5 squared is 25. 12 squared is 144. I know that 25 plus 144 is equal to X squared. Well, 25 plus 144 is 169. That is what X squared is. Your job is to find the number that multiplied by itself gave you 169. So what Blake said was, well, I know that if I'm multiplying a number by itself, the last digit, in order for it to be 9, has to be a 3 or a 7, because 3 times 3 gives you 9, And 7 times 7 gives you 49. They both end with 9. So then Blake said, I try the 9 or the 3, and then I put a 1 in it, and I try 13 times 13, and boom, it worked to be 169. If the number was 289, he might have tried 13 and realized, no, that's too small. Let me now make it 23, because it still has to end with 3. That would have resulted in a different value, which then he would have said, well, maybe it ends in 7 instead of 3. So it's just deductive reasoning, trying to figure out how to get that value. Either way, when you take the square root, so remember, when you're finding what a number is, if the number is squared, so x squared equals 169, to undo what's being done, because this is an algebraic equation, you unsquare. And to unsquare, you take the square root, and that gives you 13. That means that the length of the hypotenuse is 13 feet in this example. So this is the first type of question that you can have. That's when you are given A and B, and you're asked for C. The other type is when they give you, if you look at this, what are they giving you, leg or hypotenuse? They're giving you a leg and a hypotenuse. How do I know that this 26 is not A or B? Because it's across from the 90. So immediately, if you're across from the 90 degrees, you're C, period. That's who you are. So that means this is A and this is B. So now I put my Pythagorean theorem, A squared plus B squared equals C squared. And I know that A is 24. And I know that C, not B, but C is 26. So look at how it says A squared plus unknown squared, because that's my B, equals hypotenuse squared. Now this is the part where you're going to have to do a little bit more algebraic equations. Order of operations says you have to square first. So we square 24 and we square 26, and we get 576 plus x squared equals 676. How do I solve this equation? That's exactly right. You're going to try to isolate the equation's variable, so that x, you got a minus 576 from both sides. That's going to give you x squared equals 100. And if x squared is 100, what's x? 10. Very good. You take the square root. So this is the other scenario where you get a leg and a hypotenuse and they ask you for another leg. What's the only difference between this scenario and the previous one? Yeah, you have to solve the equation by subtracting and then taking the square root. So this is your 8.2. On the math space, you're going to have a couple of questions that when I created on the math space F 8.2, remember that there's a couple of questions, I think there's 2 or 3, where it asks about, is this a triangle? And then it has all sort of different questions like a squared plus b squared is less than c squared. You do not have to do that specific questions. You do, however, as part of the F 8.2, you have to do the questions on MathSpace, the additional assignment that's called Pythagorean Theorem 2, or Practice 2. Pythagorean Practice 2. That's what it's called. Practice Roman numeral 2. There's only 16 questions on this, and at this point I'm hoping that you guys are going to feel very comfortable being that you can use a calculator.